إلا شتي الشجرة في الطريق، هي شجرة كاينة شجرة، مي أنت واحد عبر كتخسر في اللونغاج، واش هذيك الكلمة اللي اخترعتيها أنت هي ديك الشجرة، هذيك الكلمة كتوصف لك الكلام كاين في المنهج. ميم لي ماتيماتيك هي واحد لا سيونس عندها اللغة ديالها، لونغاج يونيفرسيل اللي كتسديك كري لي شوز كي اكزيست في لا ناتور. حنا كنشوفوهم باش نفهموهم خصنا واحد اللونغاج دو لا لوجيك كتبدا بالرياضيات. الرياضيات فسرت ليا دوبوي لي شي ميكروسكوبيك لي زاتوم حتى السيباتوميك البوليكوار le macroscopique des galaxies, l'expansion millénaire, du Big Bang, par des équations mathématiques. Il avait posé la question pourquoi les maths, par exemple, l'observation du format, l'observation. Donc, il s'est par les mathématiques.
Je sais pas. Don't think it's live. Mais je pense qu'il prend une vidéo. Mais il y a moyen que ça soit live aussi. Donc. Non, en fait, c'est live. ولكن عندكم باش تكونيكتيو يو اس بي سي، عندكم باش تكونيكتيو واتش؟
Les considérés comme moi, les mathématiques, وحضرت لي كنسون في الناتور، مي حنا ما كنقدروش نقدروا نطبقوا. Par exemple, كاين دي جون CERN اللي كيسمعوا السيرش كيسمعوا السيرن، لا سويس CERN les collisions des particules ou bien في لازا ou bien في لايغون اكسيتيرا.
لا اش دي ام عندك اش دي ام؟
J'ai pas le USB-C.
T'as pas HDMI?
J'ai pas USB-C, le USB-C que HDMI et adapteur.
Oui, ok. Mais genre, ah ok, c'est ce que je voulais comprendre.
Les mathématiques, هي واحد لونغاج يونيفرسيل قدرنا نكتشفوا بها شي حوايج قبل ليكسبيريونس اللي ما خبرناش بلي لو تراموان ولا الطياره اللي كتطلع في السماء ولا اي حاجه كاينه في الناتور كتمشي بار دي سيكونسيون. هادوك لي سيكونسيون عوض ما نبقى حنا كلنا نهضروا لي سيكونسيون درنا واحد اللوجيسيال واحد البيسي لونغاج اللي سميتها الالغوريثم اللي كتبقى في الخدمه ديالنا حنا باش نوصلوا des équations. C'est ça les mathématiques. Les mathématiques, on n'a pas cherché les algorithmes. Pour l'intelligence artificielle et le computer quantique. Donc, il y a des mathématiques, des états de superposition de la matière, etc. Les théorèmes de Gödel. On aura les mathématiques. Mais les mathématiques, il y a toujours l'évolution au cas où la technologie. وحنا ما كنحسوش لان الناس اللي خدامين انا شفت لي لابوراتوار اللي خدامين فيهم لي جون راه كيحطوا لي سيكونسيون عاد كنمشيو للانجينيوري عاد الانجينيوري كنبقاو على ارض الواقع. اما حنا في الدول ديالنا ما كنشوفوش هاد الماتريكال l'application. Par contre, في الدول المتقدمين راه كيفوضوا les équations des mathématiques. C'est ça les mathématiques. عمرنا ما تحيد des mathématiques خاصة بالintelligence artificielle راه باقي des problèmes اللي ما تحلوش. C'est un problème linéaire, يعني ça prend كامل. غنمشي نحكيو على الانتليجنس البروبليم أنا نسيت لكم أنا في البروبليم puisque حنا غير واحد programmation telle qu'on vient de dire. Elle est faite غنقدر ندير لكم شي لايف المهم انا غادي تقريبا وقنا نبداو باش نعرضوا عليهم الافتتاح ديال ليفينمون ديالنا ان شاء الله. صافا بين التواصل بينكم انا غير نسمع motivation.
شحال المدة ديال تقريبا ديال الكونفيرونس شحال سمعت هاد السنة تقريبا غير السنة صافي انا مقنع صافي سي بون سي بون
على هذيك نستريح
Ladies and gentlemen, welcome to our conference on bridging theoretical concepts to application through mathematics. It's an absolute pleasure to see so many brilliant minds gathered here today, united by our shared passion for mathematics. So this conference is organized by Math&Maroc in collaboration with our partner Adria and la Faculté de Sciences de Rabat. So a special thanks goes to Sir Mohammed and Mustafa Iqbal. Thank you so much for granting us access to this amphitheater today. So before we start, I pass the floor to Sir Mohammed. Thank you so much.
Souhaiter la bienvenue à nos chers conférenciers, le professeur et M. Adria, ainsi qu'au bureau des membres de mathématiques. Je tiens à leur souhaiter la bienvenue au sein de la faculté de sciences de Rabat, qui, comme vous le savez tous, c'est la première faculté au niveau du Maroc, et ce à tous les niveaux. On a des la faculté de sciences. La faculté de sciences de Rabat, elle a été inaugurée, créée en 1957. Donc, c'est la première faculté moderne. Et la deuxième faculté de sciences au Maroc, c'est en 1968. Donc, pendant 20 ans, c'était cette faculté de sciences au niveau de tout le Maroc. Donc, elle a accompagné tous les établissements scientifiques au niveau du Maroc pour leur création. Et c'est ça qui fait que les leaders qui vivent toujours l'excellence. L'excellence, on la trouve déjà dans le fait qu'au niveau de la faculté de sciences de Rabat, hier j'étais en train de voir quelques statistiques, on a 28 contrats qu'on a signés rien qu'en 2023. On a 31 conventions qu'on a signées rien qu'en 2023. Ça veut dire qu'il y a un engouement énorme par rapport aux activités de la faculté de sciences. Et ceci est dû à la qualité de leurs professeurs enseignants. À la faculté de sciences de Rabat, on est à peu près dans les 380 professeurs enseignants dans toutes les spécialités que vous connaissez des sciences, c'est-à-dire les maths, la physique, la chimie, la biologie, la géologie et l'informatique. On a des professeurs qui sont primés à l'international dans des universités internationales américaines, parce qu'il y a des Américains avec nous, des gens qui sont de l'université américaine dans le Princeton. En mathématiques, je crois que vous le connaissez, monsieur le professeur Mahmoud, qui a eu une décernation au niveau de Princeton. On a aussi les premiers et le deuxième meilleurs chercheurs au niveau africain et arabe, professeur Shakawi. On a des professeurs qui ont eu le grand consécration au niveau de l'Mustafa Award. Donc c'est une distinction qui est donnée pour le meilleur scientifique au niveau du pays islamique. Ce n'est pas les pays arabes, c'est les pays islamiques. Donc ça englobe aussi la Malaisie, ça englobe aussi d'autres pays qui sont islamiques. Et c'est ça qui fait qu'au niveau de la faculté de sciences, on a à peu près 1200 articles par an. Cette année, l'année dernière, jusqu'à maintenant, on est à peu près 1207 articles par an. On produit à peu près 50% de la production de notre université. Et on produit en même temps à peu près 10% de la production nationale. Toute formation confondue. Donc, la faculté de sciences produit en articles scientifiques indexés, des revues indexées, à peu près 10% de la production nationale. On a à peu près 180 thèses qui sont soutenues au sein de la faculté de sciences, 180 à 200. Donc, c'est à peu près une soutenance par jour ouvrable. Donc, et ça montre la qualité de la recherche scientifique au niveau de la faculté de sciences. Nos professeurs sont coordonnateurs d'à peu près une 90 projets, que ce soit nationaux et internationaux. Pour les internationaux, on a à peu près 40 projets qui sont coordonnés par des professeurs de la faculté de sciences. Et pour les nationaux, on a à peu près une cinquantaine de projets qui sont financés, qui sont coordonnés par des enseignants de la faculté de sciences de Rabat. De point de vue formation aussi, on avance par rapport à tous les établissements, toutes les facultés de sciences au niveau du Maroc. Comme vous le savez tous, on a une nouvelle réforme qui a été initiée au niveau de l'université au niveau de l'enseignement supérieur marocain, surtout dans les formations dans les établissements accès ouvert. Donc, nous, on a 25 propositions filières de licence qu'on propose à nos étudiants, ce qui est très important. On a 5 en informatique, je crois, 7 en physique, 3 en chimie, 4 en biologie, bon, j'en passe. Toutes les informations, vous pouvez les trouver sur le site de la faculté de sciences. Pour les masters aussi qui montrent l'excellence au niveau d'un établissement, on présente 30 masters pour nos étudiants. Là aussi, c'est à tous les niveaux des masters qui sont de grande qualité. Je crois une vingtaine de masters recherche et 10 de masters spécialisés. Donc, on est content d'héberger cette conférence. Et je tiens à féliciter Math&Maroc d'avoir initié cette conférence ou bien de nous avoir touchés pour pouvoir héberger cette conférence. Ceci est dû à plusieurs choses. Premièrement, cette association Math&Maroc, c'est une association qui est sérieuse et qui travaille pour la promotion des mathématiques au niveau international, au niveau national, et puis qui soutient tous les étudiants et qui soutient les mathématiques en particulier au niveau du Maroc. Mais c'est surtout pour, et j'espère que c'est que le début d'un travail avec Math&Maroc, parce que moi j'ai vu un petit peu hier, il y a professeur Dr Bouster qui m'a envoyé un petit peu un descriptif ou bien les axes ou bien sur quoi travaille Math&Maroc, et je trouve qu'il y a des projets que je trouve qui sont très intéressants et dans lesquels on voudrait faire partie, vous accompagner ou bien travailler mutuellement dans ces domaines-là, comme par exemple Think Intelligence Artificielle à Qatar. Ça, c'est très important. Nous, on a un département, je vais vous dire juste par rapport à l'intelligence artificielle, là, il y a le ministère de tutelle qui a mis en place un financement pour le financement dans le cadre de l'appel à projet Khawarizmi qui financie les projets qui sont dans l'intelligence artificielle. Vous allez m'excuser, je prends encore 2 minutes et j'arrête. Donc, il y a eu un appel à projet lancé par le ministère sur l'intelligence artificielle. La faculté de sciences, elle a gagné, non, ça c'est la traduction après, elle a gagné 6 projets. C'est-à-dire qu'on est meilleur que 7 universités. Ça montre la qualité de la faculté de sciences. Donc là aussi, on voudrait travailler avec Math&Maroc par rapport à l'intelligence artificielle. On a un département qui est très actif, qui travaille. On a une formation en intelligence artificielle. Donc on voudrait travailler. Les journées nationales de mathématiques, on aurait de pouvoir les héberger au sein de la faculté de sciences de Rabat. Parce que, comme vous le savez, la faculté de sciences de Rabat, elle est connue par le département de mathématiques et par la spécialité de mathématiques qui est très implantée au niveau de Maroc. C'est-à-dire à ce niveau-là, elle est vraiment le leader au niveau du Maroc. Elle est connue au niveau international par les compétences qu'elle a au niveau de l'enseignement des mathématiques. Il y a aussi le projet Math&Maroc Competition, donc là aussi c'est très intéressant parce que ça crée de l'émulation chez les étudiants pour pouvoir aller dans les compétitions. Et le Summer School aussi, on est très intéressé par organiser des Summer Schools au niveau de notre faculté. Pourquoi tout ça? Parce que les études de mathématiques, il y a beaucoup, elles ne sont pas très bien connues. Nous, à notre niveau, et en tant que premier responsable de la faculté des sciences, je commence à constater que le nombre d'étudiants qui s'inscrivent dans les disciplines mathématiques est en train de régresser. Il commence à y avoir de moins en moins d'étudiants qui sont intéressés par faire des mathématiques. Pourtant, comme tout le monde le sait, surtout les grands scientifiques, on ne peut rien faire si on n'a pas des bases, si on ne développe pas les mathématiques à plusieurs niveaux. Donc ça, et là, ça attire mon attention par rapport à la thématique de votre conférence. C'est une thématique qui est très importante et j'en discute toujours avec les professeurs de mathématiques, c'est-à-dire j'essaie de l'initier par rapport à vous, c'est le pont entre les concepts théoriques et les applications pratiques dans le domaine des mathématiques. Et là, ça montre que les mathématiques, il est toujours présente dans la résolution des grands problèmes. Je me rappelle, moi, j'étais en France, j'ai fait ma thèse en France, j'avais un camarade qui faisait sa thèse en France, et il travaillait un petit peu sur des problèmes de vie courante, mais avec une approche mathématique. Ça, les gens, ils doivent le connaître. Les étudiants, ils doivent savoir que les mathématiques aussi, elles ont des applications pratiques, et que sans les mathématiques, la science, elle ne peut pas avancer. C'est pour ça que cette conférence, moi, je la trouve qui est très intéressante. Ça va inciter beaucoup plus les étudiants à pouvoir s'inscrire, à pouvoir intégrer les mathématiques. Et ça permettra aussi de faire développer toutes les autres sciences. Quand on a des mathématiques qui sont au niveau, on a toutes les autres sciences qui sont à un niveau supérieur. Donc, je vous remercie tous. J'espère que je n'ai pas été trop long. Merci.
So thank you again, for your guidance and assistance. Now, please, ladies and gentlemen, join me in extending our warm welcome to our esteemed lineup of speakers, Omar Mustafi and Adria. Just to mention that Omar and Mustafi are among the founders of the associations. So, for Omar Mustafi is a candidate in the Precision Risk and Operation Division of the Graduate School of Business Technology University. By joining he earned a Master of Science in Applied Applied Application Science from University of Paris. His research aims at bridging the gap between theory and practice of data-driven decision-making by developing methodological tools to unveil the value of data and to better leverage this data for simple operation problems. So, thank you again, for accepting the invitation. So, the floor is yours.
Thank you. Can you hear me? It's not, I don't think. Oh, should I use both? Should I use? Sorry. Okay. So, can you hear me? Okay. Oh, right. So, okay. Thank you so much for the introduction. Thank you so much for having us today. I really want to thank the organizer for having us here. It's an honor and pleasure to give this talk today. So, I try to have a very high-level talk. Usually, like, presentations are about research and papers, but I feel like you will not have such a good impact if you just present state-of-the-art research. If you want to talk more about my research, I would love to discuss that offline. But today I wanted to try to give you an overview about what is operations research, because that's the field in which I'm doing my PhD, and it's not that well known both in Europe, but also in Morocco. So I tried to answer the question, how is OR bridging the gap between the theory? So usually like when it's like math, we like the theoretical aspect of it, but with applications, because that's the key feature of it. So, okay. So I want this talk to be quite interactive. I don't like being the only one speaking, and I'm really here for you. So I will try to ask questions and see what are your takes before like talking more about things. So my first question, what are common applications of mathematics you have in mind? Everyone wants to try to have a guess. Why do we use math in real world? Absolutely, physics. So like there is this funny story that when Albert Einstein came with the theory of relativity, he didn't have the right formalism. So he did ask Minkowski about how to formalize the intuition he had to be able to have such a crisp understanding of physical experiments. So physics is a great example of that. What else? Finance, absolutely, thank you. So I can even move on. So finance is a very classical use of math. Why? Because finance is about trying to predict the future value of companies and then use that to basically make money by buying and selling stocks. So this requires a good understanding of stochastic processes, which is a fancy name for randomness. Okay, what's another example of applications in math, with using math? Sorry. Say again? Oh, cryptography. Okay, that will come later. But before that, I have one thing that, one thing that was highlighted earlier today, artificial intelligence. Even though artificial intelligence is very close to computer science, like today in terms of departments, but the real background is purely mathematics, because computer science is about optimizing functions to try to learn things. So today I will not delve into how do you do machine learning or artificial intelligence, but that's definitely something where math plays a key role. The next one is, as was highlighted, security and cryptography. So the whole banking system and most of the exchanges on internet are based on a fundamental mathematical fact. Factorizing numbers into two prime numbers is a very hard problem. So basically, that's what we call an NP-hard problem. You cannot solve it efficiently using algorithms. And this is the base of all the cryptographic aspects. So it's a lot of number theory that is beyond that. Any other example? Sorry? Yeah, that's the one I've just mentioned. So basically, cybersecurity, RSA keys, and so on. Sorry? Healthcare, indeed. So healthcare, so basically the use of math in healthcare is very diverse, either through artificial intelligence, where you use machine learning to, for instance, help doctors making better diagnosis, but also by optimizing healthcare operations. And basically, that's the last point I want to talk about. Math is used for operational purposes. But I think that the word operations is very broad and not well known. So what is it? What's operations? And what's healthcare operations, for instance? So today, my goal is to really try to introduce you to operations research and some of the simplest improvements allowed thanks to the operations research formalism. So operations research historically started during World War II. I mean, the modern version of operations research. The first version was through Monge and Laplace, but the most modern one was started during World War II, when basically in the US, but also a bit in Britain, people were trying to optimize operations. And one historical example of that is the following one. This is a simple, trivial example of how was operations used. So imagine you have these soldiers that eat lunch. At the end of the lunch, they have their dishes and they have to basically wash it. Okay, that's a very common and simple question. The way it was done is basically they have this long queue, so you have people queuing up, and then you have 4 sinks. 2 sinks to use soap and scrub, and 2 sinks to rinse. But if you did dishes, you know that using soap and scrubbing takes more time than rinsing. So what happens? Because the soaping station basically takes more time than the rinsing station, you will have a very long queue here, and people, one of these sinks will almost never be used. All right? So what is a simple fix for that is to allocate differently these stations and use 3 sinks for soaping and 1 sink for rinsing. Why is that? Because soaping takes roughly 3 times more time than rinsing. By doing that, your queue will become very short. So basically, this is a very trivial example, but this trivial example is the backbone of what is called queuing theory. Sorry, the word does not appear. So queuing theory is about how to manage waiting time in queues, and it's a very important field. For instance, in the airports, when you are having to wait at the border controls, how many police stations do you need, and so on. But also in hospitals, for instance, for healthcare, about how many nurses do you need? Who should you allocate to emergency versus non-emergency before abandonment? Because you have this waiting time, but also you have some costs associated to waiting time, either through health of patients or operational costs because of the number of nurses you're staffing. It is also widely used in call centers, where you want to have the minimum number of people working because it costs money, but you don't want customers to wait too long in line because otherwise they are unhappy. So this is like basically queuing theory is the key of all these aspects. So now that I gave you like the historical background of operations research, let me try to give you a definition. So operations research is very hard to define. Yeah, question?
Je pense pas que ça marche. Ok. Par exemple, moi, j'ai...
Non, c'est pas grave, on attend.
Ok, je m'excuse.
Non, on attend, on attend. Le but, c'est que ce soit interactif.
Oui, parce que je suis très intéressé par le sujet. C'est pour ça que,
Si.
par exemple, moi, j'ai un background en computer science et les limitations qu'on trouve, par exemple, si on parle de point de vue informatique, c'est pour ça qu'on utilise dans mon computer, c'est la puissance de calcul. Donc, toutes les théories mathématiques, toutes les choses, toute cette merveilleuse information que peuvent nous donner les mathématiques par la suite, si on veut vraiment les concrétiser, on se trouve avec des limitations de calcul. Et je pense que la recherche opérationnelle, ça nous permet plus ou moins d'optimiser plus ou moins les choses. Mais avant, juste parce que durant mon parcours général, ce que j'ai vu, c'est que généralement, voilà, ça revient même à la question, est-ce que les mathématiques, c'est une découverte ou invention? Mais je vois surtout qu'on ressent le sens que c'est une chose qui est dans notre vie quotidienne. Par exemple, c'est غير تنفيق في الصباح تمشي عند مول الحانوت وتنقول لي عطيني خبزه ولا عطيته درهم. Pourquoi ça c'est juste? Voilà, ça marche derrière, il y a une logique mathématique.
Okay.
Donc voilà, je sais pas si vous avez saisi plus ou moins ce que je veux.
C'est une très bonne question, en effet. Genre, je pense. So let me go back to English if that's okay for you. So I think the broad question was about whether. So math is beautiful because of its abstraction. Then the question is, how do you apply this abstraction to real life? Like abstracting something that is computationally inefficient is completely useless. So in operations research, like some key questions usually, and Abdullah here works a lot on that, is how efficiently can I compute things? Like basically being able to solve a problem using infinite amount of time is not very interesting for us. And today I will not go through that, but I would love to talk more offline about these issues about computation time. But I think it's very important. I will quickly hint about that in some of the applications I will present, but I will not focus on that much today. But that's indeed a very good question. So basically, like, so what's operations research? So operations research, like, it's very hard to define. So I will use one definition by people considered as the founding fathers of operations, who are, sorry, it's not working, but, so who are Morse and Kimball. So in 1951, est-ce qu'on peut laisser ça offline? Merci. So in 1951, so in their book, Methods of Operations Research, the second thing is that it is used for executive departments. So the end goal of operations research is to help people who cannot make these quantitative decisions to be empowered to do that. So it's operations research has at its core simplification. You are trying to go to the point, as opposed to like have these very complex abstract things, because you want to make impact. And people don't understand complex theory, they understand simple rules. And I will give you an example of that if I have the chance. Any questions about the definition by Kimball and Morse? Okay, so since there is no definition, there is no question, my next question is, yeah.
There's a small misconception as to what is operations research between American universities and, say, for example, French universities, where French universities, they inherit from the traditional definition of optimization. For example, the Masters of Operations Research in France is essentially a hidden optimization master's in disguise, whereas operations research in more international universities, it's more what you just said.
Yeah, indeed. So then, like, you know, every country has its own cultural thing. This is the definition from the 50s. I think at that time, operations research didn't exist in France. And I mean, the reason why France has this is because of historical reasons, like the division between pure science and applied sciences, where there, it's very hard to call something a science if there is not like much more hardcore theory. So operations being a science, they try to have more of these formalism and like theoretical aspects. So now my next question, now that I gave you a broad understanding of what is operations research, can you give me applications in real life that you are facing of operational problems? Do you have any in mind? Yeah, logistics is a very important one. Unfortunately, I don't have the slide, but that's the one key important aspect in logistics is, you know, like you have all these ports, these airports, like these supply chains of goods. The fact that you can buy and sell things in the supermarket is because there is a very complex supply chain of things manufactured in China, shipped through containers, arriving at a port, dispatched using trucks to some first big retailers who are selling to smaller retailers, and you can finally use them as a customers. So like if you imagine the complex supply chain that there is behind it, even though today it's not considered as a hot topic, basically we have faced that 2 years ago with the chips shortage. Cars could not be manufactured anymore, computers could not be manufactured anymore, all of that because we had like this issue like with the chips in Seoul. So basically, like you see how complex the supply chain is and how important it is to have good logistic operations. So one other aspect of operations is managing inventory. So basically a key point, for instance, when you are Amazon, is to have the right inventory in store so that when you are in New York and you want to have a delivery in 1 day or 2 days, the inventory is not that far. If the inventory is in San Francisco and they want to deliver it to New York in 1 day, it will cost a lot to Amazon. So basically having good inventory decision will enable Amazon to reduce cost and make more profit margin. The second example is Zara. Do you know that for fashion retail, the key distinction between, like, let's say, Gap, Zara, H&M, and so on, is how they manage their inventory. That's what makes a company being a good company in fashion retail or a bad one. It's not about the design of their clothes and so on. So any other example of, yeah. Yeah, that's a great one. And actually, that's a great one for Ghali. Ghali is actually going to talk about these zoonotic diseases and how to model that. So I will leave that to Ghali. Any other application? Traffic, indeed. I have that slightly, I don't have that here, but indeed there are like very interesting questions about routing. Like how do you route things? For instance, if you think about Waze, if you have 2 routes and Waze tells to everyone that using route A is the best one, and we are all using Waze, there will be congestion in A. So what Waze should do is to say to half of the people use route A, and the half of the people use route B. So it's like a very complex problem where like you really need to basically allocate people to the right route in the right way. That's a good example of operation. Yeah. Yeah, absolutely. Energy distribution in energy markets. This is like a key aspect of operations where basically you have to know where do you want to put your central, where do you want to put all the aspects of the grid, so that you are minimizing the probability of you having an outage. Because let's say you have something happening in your grid, the electric grid. For instance, some pylon is destroyed because of the wind. If you don't have another way for the electricity to arrive to that point, you will suffer from basically outage, which is a very bad outcome for you. So it's very important to basically optimize the way the grid is basically designed. So another one is pricing. So this is something we face every day. For instance, when you want to take a flight using Math&Maroc, you will usually see that if you take the flight 1 week before flying, it will cost a lot more than taking it 3 months before. This is called dynamic pricing. And basically, there is a whole theory about how should the price fluctuate across time to be able to make good profits. Another example I will talk later is about how pricing is done at Amazon and Uber. And in Uber, it's very exciting because their pricing is not only used to make profit for Uber, but it's also used as a means for coordination between offer and demand. And I will quickly talk about that later. There is also staffing and queuing. I've talked about that earlier. And finally, some application that is not well known and goes back to the question I've received is about auction design. So basically, if you know about auction is a way of selling an item. Let's say I want to sell this mic, and there are so many customers. So if I just post the price, let's say I will sell it for $20, the issue is that maybe someone in this room would be willing to pay $100 for it. So I could make much more money by using something different than just saying, oh, this mic is worth $20. So the way I would sell one item to multiple buyers is by having a mechanism that is more complex than just giving a price. That's called usually an auction. And there are many types of auction. The most well-known one is you raise your hand and you upgrade the price and so on. But there are more fancy auctions, and auctions are not only using arts. Actually, auctions are solved 1 million times every day once you are scrolling on your mobile phone. Because the way the ads that you see in Google are chosen is by running a macro fast auction. Basically, the way Google does that is Rally, for instance, is selling shirts, and Abdullah is selling pants. I Google something, they will bid. Rally will bid $1 for me to see his ad. Abdullah will bid $1.5. The auction will be given to Abdullah because he bidded more. So the question is, how do you design these auctions and how do you bid? And this is the reason Google is, the whole business model of Google is really through these auctions. So it's like a big market in the world. And to go back to the question earlier, in auctions, this is really the junction of econ theory, because there is the notion of utility, of incentivization. Basically, how should I design the right auction so that Abdullah is willing to give me the highest possible bid, and same for Rally. There is also the CS component, because you want these auctions to happen in a fraction of seconds, because I don't want to have latency when I'm scrolling. And there is, of course, the mathematical aspect, because you want to prove that a certain auction is optimal. So auction is really a great example of something that is at the center of 3 different fields. And because there are these 3 different fields, we are benefiting from the interdisciplinary aspect of it. How much time do I still have?
Maybe we have more 10 minutes.
10 minutes? Okay. So So basically, I will just talk about inventory management. And this is just to give you an example of how operations research help us make better decisions. So to illustrate inventory management, I will not talk about inventory. I will talk about something we have all faced in our life and is all upsetting us. And we don't understand why it's happening. I'm going to talk about overbooking in flights. So who has experienced overbooking in flights? Or in anything, hotel, like overbooking. Like no one ever went to an airport and they told him, oh, sorry, you're too late. No, Lagam does that every time. Of course, the difference is that in the US, they will pay you. In Morocco, they will say you're too late, even though you are 2 hours before the flight. That's if you're lucky. I've waited many times without money, just saying, oh, we are closed. So overbooking is the following thing. I have 100 seats in my plane. You know that like a plane, you cannot move the number of seats, like it's fixed. But I will sell more than 100 tickets. Why? Sorry? Probability of what? Exactly. Basically, the reason why I don't want to sell just 100 is because no one, like there will always be someone who has something to do at the last minute. Like, how many people registered for this event? I think they told me 180 people. We're definitely not 180. So basically the no-show, meaning people not canceling at the last minute, here should be around 50%. So half of the people said, oh, I will come on Saturday morning, but ended up not coming. So if I was pricing these chairs and I could sell much more chairs than the actual number of chairs I have here, twice more actually. So overbooking is really at the heart of that. So let's try to formalize things, to ask the question, how many seats should I overbook so that it's optimal? So, okay, the way we will model that is through the classical news vendor problem. So the problem is as follows. Imagine I have an airplane going from Casablanca to Agadir with 100 seats. Like, that's maybe too big for Agadir. But you have 100 seats, okay? So seats are sold at $200. The probability that someone does not come exists because, as we said, like some people cancel at the last second. So we will assume that the amount of people who will not come has a normal distribution with mean 5 and standard deviation 2. Okay? So basically that's an assumption we have on the behavior of people. And basically, if we sell, let's say 102 tickets and 102 customers came because no one canceled that day. For some reason, everyone wanted to travel. So there are 2 people who cannot board the plane. So what should I do in that case? Well, the way to actually do that is because they will have to wait a long time in the airport and someone will have to pay them something to apologize. So there is some fee that we will pay, a penalty, for every customer that cannot board the plane. So basically, that's the trade-off. So imagine that if a customer comes and cannot be boarded, we pay them $500. What is the optimal amount of seats to sell? Can anyone guess that? 105. That's not bad. So definitely I cannot compute that online. Like there is like some calculation that I have to run, but 105 is not that bad. So first, do we all agree? Is it obvious that we want to allocate more than 100 seats? Is it obvious that we want to sell more than 100? Is it obvious? Like if I sell, let's say 101, some cases, 101 customer will come and I will have to pay $500 more to that customer. Is it obvious that I want to always sell 101? Not clear, right? Like it's a tricky problem. So how do we solve this problem? How do we find whether it's 105, 102, 110? So the way of modeling this is through a mathematical model. That's basically how math can be done to help executives. So first, what are the variables? The variable is X, the number of seats I'm selling. And there is also like this is not a variable, but that's a realization of the word, which is C, the number of customers who will end up not showing up, okay? So what is my cost? Because what I want is to minimize my cost. Well, my cost will be split into two. So X minus C is the number of seats I sold minus people who didn't come. So X minus C is the number of people I have on the desk who wants to board. So if X minus C is less than 100, everyone can board, right? I have less customers than seats. So in that case, my cost is 200 times the difference between the capacity of the plane and the number of customers boarding. Why is that? Because I could sell more tickets. Like there is this missed opportunity cost. Is that clear? Why is this cost here? So basically, because let's imagine there are 90 customers who came. I could sell 10 more because like I could have made $200 per customer more. So $200 times the difference between how many seats I have and how many customers came, okay? So that's the first type of cost. It's called the underage cost because I'm selling less than I should have. There is an overage cost. If I sell too many items, basically, and not enough customers are canceling, I have more people than seats. And as I said, I have to pay $500 per customer. So basically, that's the second type of cost. So if I order too little, I'm losing in some sense $200 per customer missing. If I sell too much, I have $500 per customer in excess. So it's an asymmetric cost. So it's not clear how many customers you want to, how many tickets you want to sell. Are we clear on the problem formulation on the cost? Okay, so if I know exactly the number of cancellation, like imagine that I can look in the future and say, oh, I know 3 people will cancel. The optimal solution is obvious. I will sell 100 plus the number of cancellations. But obviously, I cannot know how many people will cancel. So I have this probabilistic assumption that I told you about, that normal distribution, normal distribution. So what I will do is I will try to minimize the expected cost. I want to minimize my cost on average. Basically, because I'm playing this game every day, like I'm a big company, I'm L'Arabe. Every day I am playing this game. So like, in average, I will see the normal distribution appearing. So that's what I want to minimize. How do I minimize this function? Anyone has a guess? How should I solve this problem to have a solution? Like a general tool. Yeah. Sorry? Yeah, that's a good question. That's a good way. Like I know the demand distribution, I know the cost, I can compute it. Like X as a function, like build the X function, sorry, the C function, and pick the point that is the lowest. Now, if I want to prove the minimal solution, as opposed to like solve it numerically. Sorry? Simplex. Oh, they're much more simple. Yeah, you could do simplex, but this one is simpler. Yeah, I heard it. Yeah, I will differentiate it. I will take the derivative. So you can show that the cost is convex. I will not go through that proof, but because the cost is convex, I can like find the minimizer by just solving like the differential being equal to 0, and then I will find that the optimal solution is around 104, which is roughly the 105 I heard. So basically, what do we see? Is that overbooking by 4 seats is optimal, even though I will pay $500 per customer in the case where more customers than 100 show up. So like $500 sounds like a lot of money to pay people, but still, provably we have shown that the actual right way of selling this ticket is by overbooking a bit, and because of randomness, it's okay. You will make money. Like that's the best way of making money. Yeah. Absolutely. Yeah, so that's a great question. I will go back to that later. Like we have a lot of assumptions. So, yeah. Yeah. Absolutely. I'm going to go to that in 1 minute. But indeed, here there is a key assumption, which is that like we know the distribution of the constellation. So I know roughly how people behave, and there is the question, how do I get to that? I will go to that at the end of this slide. But there is another thing. You may want to understand more broader managerial insights, as opposed to like saying, oh, the normal has a mean 5 and the standard deviation 2. Let me give you a general solution, like that can be applied more generally than like having these exact numbers. So if you have a general normal distribution with mean mu and standard deviation sigma, by using the differentiation method, we can show that the optimal stocking is 100 plus the mean plus some coefficient times the standard deviation. Now, how does this coefficient depend on, this z coefficient will depend on the ticket price, which was here $200, and the penalty fee. If the ticket price is more than the fee, so basically imagine I'm only giving $100 to customer if I'm overbooking them, and they pay $200 to sell the ticket, sorry, to buy the ticket. Basically there, this z will be positive. So if the demand is more variable, I want to overbook more. Why? Because basically it does not cost me as much if I am wrong, I have booked too much, than too little. So I want to overbook more to hedge against uncertainty. In the contrary, if the fee is more than the price, then this z will be negative. And that means that if I have more variation, I want to be more conservative and overbook less. So what do we learn from here? But we learn that it's important to understand the trade-off in your business to do the right thing based on the type of uncertainty you are facing. Basically, if you don't know well what's your price and what's your penalty fee, you can have the wrong insight. You will think that to hedge against uncertainty, you have to book more as opposed to less. So it's important to be able to frame well the trade-off. And the second question is, you want to also understand like the type of uncertainty you have. You want to estimate these variance, this mean. And you can also ask why normal distribution? Why not Poisson? Why not log normal? So now, because I don't have time anymore, I will jump right away to the conclusion. So basically what does this tell us is that operations research enable us to inform decision maker by isolating first order trade-offs. What does it mean? You want to really understand what is the key aspect of your problem that will enable you to save money. Basically, when you are doing airline, you don't want to go to like very complex, oh, what's the difference between the fare for 12-year-old child, 60-year-old senior people, and so on. No, first let's just understand one price for everyone, one fee for everyone, what is the right overbooking, and there is something non-trivial to learn from there. How to hedge against uncertainty in this case. The second thing is that operations research help you to think about uncertainty. For instance, here we had this normal distribution assumption by using probability theory, but it also helps you think about decision by using optimization. Basically, our optimization variable was the final decision, and we had one model of the uncertainty in the world through the normal distribution. And there is a last question, which is, how do we come up with this understanding of the uncertainty? And this is the recent trend in operations research, which is basically mimicking the recent trend in the whole field in science. It's about learning things. So basically, how do you use past data to basically be able to estimate that the demand follows a certain distribution of probability and then optimize it from the samples as opposed to optimizing it by assuming a model. And that's basically what my research is about. I work mainly on these data-driven decision-making problems. With that, I would like to thank you. Okay, we have time for Q&A? Okay, so we have how much for Q&A? Okay, we have some time for 3 questions, I guess. No, they have to use the other mic. Oh. Yeah, no, that's, I think, a great question. So the question is, how did I end up doing research related to that? I would say, okay, so when I was at Polytechnique, what I really liked was algorithms and the fact that there is this very nice thing in computer science theory that says that for some problems where finding the optimal solution is impossible, that's called like NP-hard problems, like it's require infinite amount of time, like a lot of time to basically be able to solve the problem, we can derive approximation algorithms that will give you a solution that is close to optimality, but not optimal. And the beauty is that you can quantify how suboptimal that solution is, even though you don't know what's the optimal solution. And that's like philosophically something that I found very appealing. Like you can know how bad your decision is without knowing what's the best decision but by computing some bound on it. So, and that has like great applications in practice. I would like to talk more about offline, but really this idea of like being able to like make good decisions in complex problems was very appealing. And then operations were like a more applied aspect and impactful aspect than computer science theory. So that's how it ended up like that.
Tout d'abord, je tiens à vous remercier pour une merveilleuse présentation. Alors, ce que j'adore moi dans la recherche opérationnelle, alors c'est que là on trouve toutes les mathématiques, on trouve c'est de l'optimisation, c'est de la théorie des probabilités, des statistiques, etc. Et vous avez déjà parlé sur comment on va modéliser une telle situation en utilisant une loi de probabilité. Je pense que toujours lorsque n est assez grand, on peut supposer que les variables sont indépendantes. Donc on peut utiliser le théorème central limite pour dire qu'on peut l'approcher par une loi normale. Et dans certains cas, il faut que tu sois un expert, par exemple, pour dire qu'une telle, les données elles vont suivre une telle loi. Est-ce que vous avez déjà une loi que vous les utilisez en tant qu'expert dans ce domaine ou juste toujours vous utilisez la loi normale?
Ouais, ça c'est une très bonne question. Je pense que la loi normale est une mauvaise approximation dans la plupart des cas. La raison pour ça, c'est qu'en effet, le théorème central limite ou la loi des grands nombres va s'appliquer, mais on part sur l'hypothèse que les données sont IID, which doesn't happen in practice. For instance, let me switch to English. If you go to retail, like inventory management, like the demand, the usual law that would be used is, for instance, in big companies, is the gamma distribution. So usually the way you will do that is you fit the parameters of the gamma, and then you will try to come up with like what's the right shape of the distribution. Another important law actually is the log normal, or the power law, because most customer behavior and demand behavior are heavy tail. So the normal has a very flat tail, like a very thin tail. It converges very quickly to zero at infinity. But in practice, very often you will see that like the demand of your product has a long tail behavior. You have many products which have a high demand and many products with very few customers coming. So like, you have this very long tail aspect. So normal distribution would be a very bad assumption in this kind of setting. So I would say like in many practice, normal distribution is too simple. Oh, that's a good question. So there is this, like in this recent trend of literature in operations. So machine learning and statistical learning has this classical use of MLE. So maximum likelihood. So basically you fit the way, you find like for people who don't know what it is, you try to find the way that is the model that is the most likely to explain the data you have seen. Okay? So basically if I have a coin, I'm tossing, pile ou face. and I see 100 pil and 0 face. In that case, well, the fact it's quite unlikely that the coin has like a 1/2 probability. So more likely, pil has some probability of appearing that is close to 1. So that's the MLE estimator. Well, the issue with that is that when you go to operations, basically estimating the best distribution for likelihood is not the best way of using a distribution for decisions, because certain decisions are more sensitive to certain type of distributions than others. So basically there is this recent trend called smart, predict, and optimize, where you want to incorporate the estimation process with the decision model that you have at the end. Because you are not just trying to predict things in the ether, you are really trying to solve an optimization problem at the end. So you want your prediction to be robust to the optimization problem you have. So that's like basically what state-of-the-art research is working on. Yes. Oh, there is.
C'est pas une question, mais juste une remarque à propos des méthodes itératives approchées. Des fois, on a la possibilité de trouver une solution optimale par des méthodes exactes, mais ça coûte plus. C'est pour cela qu'on procède par les méthodes approchées.
En effet. Yeah. Allah. Comment? Ok.
Thank you for the presentation. Really appreciate the presentation. So maybe a few words, if you can add, about the limitation of research operations. You talked about using it for optimizing the traffic lights, optimize the path for cars. But for example, you can't use it for estimating the quantity of materials to build a bridge.
Say again, sorry?
You can't use it to estimate the quantity of materials to build a bridge, for example. So what are the limitations for operation search?
Well, there are many. So I would say the main limitation, I think that there is this beautiful trade-off in operations research, which is about specificity to a problem versus generality. So, and that's actually like an overall risk when you are doing research in this field. As a mathematician, you want to have a broad theory that applies to everything. But as an operational researcher, you need to have like a crisp understanding of a particular problem. And for that, you need a model. So for problem, and all models are wrong. Like this is like a important thing to know. Like we never make a true model. Model is just an approximation to real world. So for instance, like in problems where modeling is very hard or nearly impossible, or when the problem is too sensitive to misspecification in the model, basically you cannot make good decisions based on your models. So you have to use alternative methods. So operations research cannot stand alone. It's usually like a field that borrows a lot from econ theory, because you really want to model the way customers are behaving, the way humans are behaving. But it uses physics when it's about energy or resources in general. But as a standalone field, it is a very fragile field. So that's one of the main limitations of that field.
Yeah, thank you very much. Let's thank the speaker again.
Thank you.
So thank you everyone for this insightful presentation. Now we proceed with our second topic, our second speaker, Math&Maroc. Please join me in welcoming Math&Maroc. By the way, he's also among the founders of Math&Maroc. So Math&Maroc is a PhD candidate in operations research at MIT. His research tackled 3 general topics: human health, industrial systems, and public service operations by designing new models for machine learning optimizations, stochastic process, and technologies. Before pursuing his PhD, a Master of Business Analysis from MIT and a Master of Science and Mathematics from Wokeliة. So thank you very much for accepting the invitation.
Thank you. Thank you very much. Thank you. I think if we can just put the slides, please, that would be great. That's it.
That's it. Okay.
Okay. Hello everyone, Assalamu alaikum. I am Ghali Zarwani. I'm doing a PhD in operations research at MIT. Before starting the talk, I'd like to really thank Safa and the whole Math&Maroc team for organizing this conference. It's really a pleasure to see the Math&Maroc flourishing and the ecosystem of mathematics in Morocco really growing up, and I hope we really continue towards this journey. So, as I was thinking about the theme of this conference, so how to bridge between theory and practice through mathematics, I really was thinking about what were the right frameworks that we could use to think about a research project. I think that a lot of us here in this room are either researchers, PhDs, or future PhDs for some. So what could be the right framework to think about a research project? So before we start, I'd like to ask the audience, and especially those that have done research, in their experience, what was the most challenging step in their research? So what was it for you? To find the best method, so a methodological aspect. Any other challenge that has been faced in the past? Sorry? Yeah, you are going to nowhere. So finding a direction, finding a path, an objective. So I think that throughout the experience I had, the first and main challenge that we have in a research project, especially in the math field, was finding an important problem to work on. So what does important mean? Important is a very broad and very subjective term. It could be important from a theoretical perspective. It could be important from an application perspective. It could be important for a context. The important problems that we are facing here in Morocco are different from the important problems that other regions are facing. So, and actually, what happens is that this first step, finding an important problem to work on, is usually 70 to 80% of the work. Because once you find an important problem to work on, you are motivated to work early in the morning and to work hard on it. And you also have an ecosystem that could provide you data that could help you solve this problem because it's an important problem to work on. So I really want us to really not jump into the modeling and jump into the theory, but really step back and say, okay, I want to find an important problem to work on. Once we have identified this problem, I think the second step in the analysis is to build a scientific intuition. So it could be an intuition through physics, through math, through chemistry, through any other field. But I think that before going into the math and before going into the theory and the academic side of a project, it's important to have an intuition, to understand the dynamics, and to understand what are the different factors that can play and have a role in the problem. The third step that follows is to build a model. I think that having a framework, a scientific framework to characterize your problem is key to communicate your results and your insights. So identifying or building a model is probably the third step that we could follow. And after that comes the fourth step, which is deriving practical insights. Because we want to think about an important problem, we want to build an intuition, we want to build a formalism of it, and ultimately we want to have some impact on the ground. Impact through advancement of a theory, or impact through advancement or to the improvement of a practice. And impact also go through publications. We also want to write and communicate about the problems that we have done and go to conferences and share and learn from each other. So this has been the framework that I've been using so far throughout my research journey. So finding an important problem, building an intuition, developing a model, and ultimately derive some practical insights. And I'll try to illustrate this framework through two examples and through this talk. So in this talk, we'll try to illustrate this methodology. And the first step in the methodology was finding an important problem to work on. So personally, I was interested in the area of global health because healthcare was something that was dear to my heart, and I feel that for me, it was important to be healthy and so on, but specifically global health. So global health is really, there's a difference between the individual health and the global health. So the global health is the health of different populations in different regions of the world. And the second topic of interest that I had was agriculture. Oops. So agriculture because, well, I grew up in Morocco, I am Moroccan, and we know that agriculture in Morocco is a really important industry and sector. So when I started my research journey and when I started my PhD, I was exploring some important problem at the intersection of these two. And I found out that actually there are many questions at this intersection, but there was one that was particularly important, and it was the question of zoonotic disease. So I'll focus on this point, but zoonotic diseases basically are viruses or diseases that transmit from animals to humans. And I was motivated to work on that really during the COVID pandemic, because I started the PhD during that period, and I was thinking, okay, what kind of other diseases are similar to COVID? And there is a large family of such diseases, which are zoonotic diseases, the ones that transmit from animals to humans. So, oops. Okay, so hopefully we'll get to it. So in the meantime, please don't hesitate to interrupt me if there are any things or any questions. So we were saying zoonotic disease. So throughout this talk, I will focus on this specific part, zoonotic diseases, and I will try to illustrate this framework, so these 4 steps, with 2 examples. One example that will be more methodological, and it will be about the development of a kind of model to understand why there are outbreaks of these zoonotic diseases. And the second will be more of a machine learning flavor that will enable us to develop an AI type system to tackle these, the outbreaks of this disease. So this will be the setup of this talk, and I was wondering if there is anything unclear in the room before we start. Yes, please. Yeah. So to build the scientific intuition, so I put with data in parentheses, because indeed it could be sometimes we will not have data. So, and sometimes some people are more interested into the theory, so the data component is between parentheses, depending on the preferences of everyone. All good? So, as we will see, so Omar previously talked about what is operations research in general, and there is one subfield of operations research that is more applied, and that is called operations management, and both of these talks are within this field. And please, just throughout this talk, remember with me these 4 steps, because we'll use them as a framework of thinking. So, okay, the first, we can start. The first example will be about the development of a supply chain epidemiology model for zoonotic disease outbreaks. As a reminder, zoonotic diseases are viruses that transmit from animals to humans. And actually, when I started looking at this type of diseases, they are a really important challenge for global health. According to the CDC, the Center for Disease Control, which is a public health agency, 3 out of 4 infectious diseases in humans emerge from animals and are actually zoonotic disease. Among them, there are some that are very important, such as avian influenza, swine influenza virus, SARS or SARS-CoV-2 that we unfortunately faced recently. And there are some others like Middle Eastern respiratory syndrome. So this will be, I noticed that this was something that is very important for public health, and this was something where we could develop something related to operations. So in addition to that, and here there is the link to agriculture, zoonotic diseases happen to emerge from the agricultural supply chain. Specifically, they happen to emerge from live animal markets that sell live animals. Like basically here, so in Morocco, where we will have some live animals. And there are, if you have been to these markets, there are two types of markets. There are the small size markets that are called wet markets, and there are the larger size that are called wholesale markets. And we observe that actually most of these, the outbreaks happen at the level of these markets. So I was digging more into that, and I was trying to understand why do we have these outbreaks at the level of this market specifically. And we are also trying to understand basically what is the position of these markets within the agricultural supply chain. So let's try to understand that a bit. So when we look at the agricultural supply chain, we observe, and this supply chain is very typical for emerging countries, and it's typical for Morocco as well. We observe that there are multiple farms that are smallholder farms. So very small farms with 2, 3, 4 hectares per farm. And each of these farms have their own environment, feed, supplies, and practice. These farms will then supply the markets, which will be either the large wholesale markets or the smaller wet markets, which will then supply retail stores, restaurants, household consumers. So we see here from this data or from this structure that markets are consolidation points for the supply chain. So there are millions, or there are, for instance, I took the example of China because it was a, COVID and emerged from that region, because we observe that there are many, many more farms than markets. So we see that, for instance, in China, there are more than 18 million farms that supply only a couple of thousand markets. So markets act as a consolidation of the flow from farms to markets, which then supply the retail stores also. In addition, they house a large volume of trading, like somewhere around 52 million tons for poultry only. And in addition to that, they act as the largest interaction point between animals and humans within the supply chain. So when I looked at that, I said, that's it. That's probably the reason why these markets are the area where there are the outbreaks, and that's the end of the story. There is no more things to do. But when we look at the details, there is actually more to that. There is more to that because when we observe the field studies on zoonotic disease, we observe that farms actually are the origins of this disease, but at the same time, there is not much infection at the level of farms. Farms are really safe. However, the infection rates at the level of markets is much higher. We observe up to 56% of the samples that are taken from farms being infectious. So there is really an amplification of the infection in the market, in addition to the fact that it's just the interaction between animals and humans. So there was something more to that. So here, throughout this couple of steps or couple of slides, we have gone through step 1. Identifying an important problem to work on. And we have basically came up with a question, which is how to explain the amplification of the infections at the level of markets. So this is the question that we try to ask. So as in any kind of research journey, the first step is to test the literature. So I looked at classical epidemiological model, and someone in the audience has referred to epidemiology before. And basically what happens is that when you apply classical SIR model, SIR are classical epidemiological model called susceptible, infectious, and recovered, these models actually apply to a closed system. So basically the population in this room and the evolution of the infection within this room. However, as we have, our system is an open system. There is a market that receives a flow of poultry, and the flow of poultry exits the market. So the market is an open system. So the models that existed could not be applied to this context. And in addition to that, even when we applied them, we couldn't really explain why there is this amplification at the level of the market. When there is an inflow of small infection, the outflow of infection remains small, so we couldn't explain what was happening with the literature. So we needed to develop some new research for that, and this motivated us to work more on this topic. So we have said, step 1, identify a problem. Step 2, modeling and building an intuition. So let's try to build an intuition together of what's happening. So here, basically, we have the supply chain, the agricultural supply chain, and in this supply chain, there are multiple farms that supply the market. These farms are pretty safe. They have a very low infection rate. So here there is for instance, one poultry that is infected. This poultry supplies, this supplies consolidate at the level of the market. There are direct infections from infected poultry to safe ones. Then we observe that the market is actually composed of an environment that has samples that could be infectious. And this environment is composed of cage surfaces, feather, residuals, and other components that could host and transmit the infection. So there is also infection from the environment, which is the second component. So by the end of the day, there are a couple of poultry that are infectious and that leave residuals in the market before leaving it. Okay, so the second day, what happens is that we have another new batch of poultry that is relatively safe from these farms that comes to the market. There is direct infections, but no, the infection from the environment is even higher than the day before. So there is even more poultry that gets infected that shed even more residuals into that market before leaving it. So here we started to get the intuition of what's going on. We started to understand that there is an amplification of the infection in the environment of the market. And now that we have some intuition, let's get to the math. So we need to build a formalism. That way, we introduced the transmission interaction persistence. So basically, we were thinking that this intuition that we built was based on 4 main components. The first one was a transmission of the infection from infected individuals to safe ones. This is the beta. The second was the interaction of the infection with the environment, the alpha. So we said there are residuals that are left and that could infect back the safe poultry. And there is a persistence of the infection through time. There is an amount of infection that is here today in that market and that will be persistent to the following day. In addition to that, we will associate with the market an environmental risk, ET, which will be the risk that there could be an infection from the market to the poultry. So this was the formalism that we chose to use. Let me pause here to sense the room and see if there is anything unclear. Yes.
In markets. So we have the same situation. The poultry that infected the others was in a farm before. Why did it infect others in that farm as much as it did in the market?
Yeah. So that will be more of an that will depend more of the context of agriculture, in the sense that the practices, the sanitation practices that are applied at the level of this farm are much more regulated and stricter. So they happen to be much more safer, and also the density is safer, is smaller at the level of farms. So that's why they were safer. Okay, sounds good. So we have the formalism. We have gone through step 1. We have gone through step 2, building an intuition, And now we are at step 3. We are building a model. So we build the formalism, and based on this formalism, we build the model based on 2 main mechanisms. The first mechanism will be the mechanism of infection. So let's see what is in there. So this mechanism of infection will depend on the inflow of infected animals from the farm. So this will be ETIN. So the sum of the inflow of infected animals at every time T from every farm K. Then the inflow of safe batches, so STK from at every time T from every farm K, the transmission rate and the environmental risk. And what we see here is that the outflow of infection from this market will depend on some direct infections that are some direct infections that happen between the safe and the infected animals. But you will also observe that there is an environmental infection that happens. And this is our main innovation. There is some environmental infections that happen between the environment of the market and the susceptible individuals. In addition to that, the second mechanism will be the update of the environmental risk. So we have seen that the environment plays a key role in our mechanism, and we need to understand how does the risk of infections from that environment evolves over time. So we need to model this update. It will depend on the outflow infections at every time T. So basically the amount of infected poultry that comes out of the market divided by the total outflow of the market. And this update will be basically equal to the persistence of the environmental risk over time. So gamma ET, so how much environmental risk persists from T to T plus 1, plus the new environmental risk that is introduced to the infection that happened at the market. So here we have an interaction term times an infection rate. And at every time there is a sanitation, every time we sanitize the market, at big T, we'll update this environmental risk to a reference value. Okay, so we have gone through step 3 now. We have built the model, we have built the formalism, and we'll try to derive the analytical insights. So step 4. So, well, we are a group of mathematicians, so we like theorems, and we'll start with a first theorem. So this first theorem says that the outflow infection from markets can be in 3 states. It can be either in a stable state, basically the outflow of infections will be safe. It could be in an approximate linear growth state, so it could increase, but it will increase slowly, so it will be fine. Or it could be in an exponential growth state. And in that case, it will correspond to an outbreak. So let's see if we observe this in simulations. So when we simulate the model, we observe that actually there are these 3 states: the stable, the exponential growth, and the approximate linear growth, and the exponential growth. And we see on top of that, being in one of these states is highly sensitive to the parameters. It's highly sensitive to the interaction, to the persistence, to the transmission. And here I want to really mention something in our framework, which is this approach, step 1, 2, 3, and 4 is iterative. Once we are at step 4, we have some ideas to come back. Once we have some step 4, and we have derived some analytical insight, we have some ideas that could help us come back and improve our model. And this is what we will do here. When we observe that there is a high sensitivity to the parameters, we thought that these parameters are not fixed. These parameters depend on nature, they depend on the climate, on the environment, so they are not fixed by definition. There is a perturbation to these parameters. So we needed to revise the model and we needed to improve it. So this is how we introduced a stochastic version of the model, where we took our parameters, so the transmission beta, the interaction alpha, and the persistence gamma, and we added to it a Brownian perturbation to model this perturbation effects of the climate and the environment and so on, and randomness in general over time. In addition to that, we also added an effect of seasonality, because we thought that, well, during winter season, the persistence is higher because the climate is colder and more humid. So we needed to adjust also the persistence risk parameter. Okay. So now we have revised the model, and this enables us to have a second analytical insight. It enables us to say that, to enable us to quantify what will be the risk of an outbreak in a market. Basically, before that, we needed to define what is an outbreak. So an outbreak will be the evolution of the infection from a stable state or an approximate linear growth state to an exponential growth state. And we were able to quantify the risk probability of this outbreak. And this will be basically the probability that WT, which follows a normal distribution with standard deviation T, higher than a certain gap, which depends on the parameter. And basically, we were able to say that once we increase the sanitation period from T1 to T2, so for instance, from T1 1 week to T2 2 weeks or 1 month, we increase the probability of an outbreak by this ratio. Okay. So this was the second analytical insight, and we simulated the model to observe this in practice. And what we saw is that here we simulated the outflow of infection over 10 years from a market, and we saw that for a market with a sanitation period of 1 day or 1 week, the market remains relatively safe. However, for a market with sanitation period of 30 days, we observe that there are sometimes outbreaks that are happening. So actually, this was somehow, this enabled us somehow to quantify the evolution of the risk of an outbreak depending on the sanitation period. And this is, here we are at step 4, deriving some practical insights. So we'll continue in that step 4 and we'll further analyze the model. So we looked at some data and we were saying, okay, how does the evolution of the infection with an example of such diseases evolve? So we took the example of H7N9, and we observed that for H7N9, which is a type of avian influenza that we might have heard of a couple of years ago, probably 10 years ago, we observed that the amount of infections remained relatively small up to 2017 when there is an outbreak. And this outbreak is happening at the same time that H7N9 becomes highly pathogenic. So, and highly pathogenic really corresponds to our interaction term here. So the larger the interaction term, the largest the risk of an outbreak, and this is reflected in the data here. In addition, in our model, we really focused on the environment as a key component of infections. And we see here that when we model on the left side, when we model the outflow of infections without the environment, we don't observe any outbreaks. However, here we observe that outbreaks happen with the environment. So the environment really plays a key role. So this was kind of the punchline of this paper. The punchline is that we needed to understand both the supply chain and the epidemiology to model this question of zoonotic diseases. We also needed to model it, and we also derived some practical insight in the impact of sanitation and the environment. So as a result, we were able to say to public health agencies, pay attention to the environment. This is the reason why there are outbreaks. So this was our first example, and this was our step 4 in our analytical framework. How are we on time? Are we good?
Maybe we have like 5 minutes.
5, 10 minutes? Okay. So I'll move to the more AI type of modeling, but let me stop here to see if there is any question in the room. Yes.
Please, can you wait just for a moment?
Vous utilisez des données pour valider votre modèle?
Oui.
La validation, c'est ça?
C'est cette partie, absolument.
Okay.
So, ici, donc, to use, sorry, I'm more familiar with English for the technical terms, but basically the data could be used 2 ways. It could be used to model, to build the model, And here it wasn't really our case because we didn't have any data to support the building of the model. However, the data here was used to build the outcomes of the model, to motivate the model. This is what we've seen at the beginning with the rates, and to explain the outcomes and to validate the outcomes of the model. This is what we have here with the case of H7 and 9. All good?
I think there is some relationship between percolation theory and percolation theory. Do you know what?
Yeah, percolation.
Some relationship between these two things.
Yeah, you can think about it that way. Yeah, as well.
I think something that's happened before. We know that this peak here.
Yeah.
I see something like that on percolation theory.
Yeah, actually, percolation has been used quite a lot also in epidemiology in general. So
exactly,
there's definitely a relationship.
Thank you.
Okay, perfect. Yes, back in the room.
Merci pour la présentation, c'était fascinante. Mais ma question à moi, c'est que sur le data, la fiabilité de data.
Oui.
C'est-à-dire que sur le plan commercial, on ne peut pas vous donner, un vrai data consécutif, c'est-à-dire la fiabilité des données.
Oui.
Parce que je bâtis mon modèle sur des données quantifiables, ce qu'il n'y a pas un processus pour s'assurer de la fiabilité. Parce que lorsque je parle de market, je parle de marque, je parle de label, je parle de pas mal de choses. Je ne peux pas fournir un data, donc ça peut bouleverser les calculs et le modèle.
Oui, absolument.
Surtout en épidémiologie.
Oui, absolument.
Parce que j'ai vécu un cas... C'est bien que vous avez évoqué les zoonoses. C'est très difficile. En fin de compte, la transmission de... Par exemple, il y avait un déplacement au Maroc des habitats dans des fermes. On leur a donné des maisons ordinaires. Alors, les gens ne peuvent pas se détacher de leurs animaux.
Oui.
Ils les mettent dans la cave.
Oui.
Et alors, on était surpris dans un coin qu'il y avait de la brucellose.
Oui.
Et la brucellose, vous savez très bien que ça tue.
Oui, absolument.
Et c'est une zoonose parce que c'est l'urine des moutons avec le jeu. Donc, personne ne voulait nous donner vraiment les vraies causes, les données. Donc, je vous remercie parce que je veux vraiment, ça me touche à cœur, surtout la fiabilité des données, surtout les marchés, je doute fort.
Ouais.
Pour moi, c'est un problème de data.
Oui, oui.
Donc, le modèle, est-ce qu'il y a une approche pour dire, voilà, c'est...
Oui. Oui.
Merci.
Non, je vous en prie. Par rapport à la question des données, basically, the quality of data is key here. The quality of data is even more important when we are talking about sensitive topics. So this is a sensitive topic. It's not about a price or a revenue. It's really about health. So getting data about health is even more pressing. And for our case, I'm thinking as in general, when we are building a model to be robust, so to be robust to this question of data quality, there is an important step of sensitivity analysis. So we need to stress test our model against extreme cases of of the potential data inputs that we can get. So we have run a sensitivity analysis. I have not explained here, but I'm happy to go through it in the details. So sensitivity analysis is the way to, and sensitivity analysis and robustness are the way to go to stress test against data quality. Okay, so I'll take probably 5 more minutes to go to the second approach because I really want to give this example. So basically here we have gone to a modeling approach, and there is there's this growing field of machine learning and AI, and basically in our research field there is more problems that we can tackle with AI and with such tools. So this second example that I'll probably go through briefly is about how we can develop an AI system to tackle a specific problem. And here it will be the problem of COVID-19 variants. How can we basically identify COVID-19 variants with an AI system? So basically we'll keep our 4 steps, right? The first question that we had is, we were exploring data about SARS-CoV-2, and we were observing that when we were looking at the evolution of the infection cases over time, when we were comparing this to the distribution of variants over time, we were saying that at every wave, there is only one variant that drives this wave. So here we see that there is one variant, here another variant, here only a few variants, and here as well. So we continue to explore this avenue. This was an interesting problem, and we also observed that meanwhile there are only a few variants that lead to every wave. There is actually more than 1,500 variants that are reported. So there is 1,500 variants that are reported, and only a few are actually risky. And the current public health agencies basically have a qualitative and hand-wavy way to classify this variant. So here we were saying there is something to explore here, and the research question that we came out with is whether it will be possible to have an early prediction of infectious variants, whether we can predict early enough those variants that will be infectious and that will spread in the population. So this was step 1, identifying an important problem. Step 2, building an intuition. So when we collected, and here to the point of data is very important, and here we were lucky because there is a lot of public data available on the genetic sequences of SARS-CoV-2. And actually, I encourage you here to look at it. It's a database called GISID that provides a lot of genetic sequences of SARS-CoV-2, but also other viruses. So we looked at these genetic sequences, and we were saying that it is composed with different proteins, so spike and N and some other proteins. And basically that from one variant to the other, there are different mutations that happen. So in variant I, there are mutations here, for instance, in the spike, and here in other proteins. And in variant J, there are some other mutations that could be happening. So given these differences in the mutation, we could build a distance between the variants. So this distance will be depending on this mutation sets. And let me not go to the details of this distance, but basically here we have 2 genetic sequences, and we build a distance between them. In addition to that, we are still at step 2. When we computed this distance, we saw that the variants are very different from each other. The variant that led to the first wave is almost 80% different from the variant that led to the second wave. The Delta variants are almost 95% different from the variant that led to Omicron. So there is a big difference between variants. Still, in building the intuition, we saw that variants could have very different spread. Let's say, when we look at the variants evolving during the 2 first weeks, 2 variants can evolve very similarly in the 2 first weeks of their evolution, but one can be very infectious 3 months afterwards, and the other cannot be infectious and can be safe. Actually, most of the others are not infectious. On top of that, variants can have different spreads in different populations and different countries. One variant can be very infectious here in Morocco and not infectious at all in another country, say Senegal or say somewhere in Europe. So we were saying that there is variability in the spread over time, and there is variability in the spread over geographies. And we saw that there is the distance that really here could play a key role. So we were trying to build an intuition, and now we need to build a framework. So this will be a different framework from the one that we had in the past, and it will be a kind of machine learning type framework. So basically, we saw that we took a variant and we said, okay, let's take this variant and let's observe it for the first 2 weeks. We observe it, we derive some genetic features, and this is based on the distance, but we also derive some infection trajectory features and some features on pharmaceutical and non-pharmaceutical interventions. And then our objective was to predict whether this variant can be infectious 3 months afterwards. So we trained the model. Basically, we took a tree-based model. We trained it from up to March 2021. Then we predicted from April to January, so around 8 months afterwards. So this was the framework that we have developed for that. And basically, now we move to step 4, deriving some practical insights. So we needed to assess this model, and we observed that this model was quite sensitive in the sense that it was able to predict what were the infectious variants. It was sensitive up to 78% after 1 week of observation and up to 80% after 2 weeks. But it was also specific. So specificity was also important because it was able to say these variants are safe and we can leave them aside and we can really focus our resources on the infectious variants. Okay? So this was the main practical insight that came out of this work. So given the time, I'll conclude with that and really hope to finish with this framework. So we have really gone through this framework, these 4 steps, identifying an important question, building an intuition, building a framework, and ultimately deriving some practical insights. We have gone through a modeling example and a machine learning example. Thank you for your attention. Yes?
Thank you for the presentation. I have a question, please. As we know that we have to follow 4 steps to develop a model. In Morocco, most of companies fight to develop a model, but they don't take time to define the accurate data to make this model. So my question is, what is the steps that we need to define the data needed for a model?
Yeah, absolutely. So to your point here, I think your point refers to the step 2, building an intuition. And obviously, for instance, for the first problem, it was more theoretical in some sense. So we didn't need much data to build the model. But for the second, it was heavily data-driven. So the data was really important to build the intuition before even running the model. So I think that data is key here. You said that basically a lot of work comes into the data, into finding the right data sets, into engineering and processing these data sets. So I think this also kind of echoes the latter question on the sensitivity of the data. So I don't have a really precise framework to say about how to integrate the data and so on. But in general, the approach that I've been considering in the recent years is basically to take as much data as possible that could be relevant to the problem. So there should be some motivation to that. So here in the second example, it was genetic data because without that genetic data was important. It was infection trajectory data because without from an epidemiological perspective, that was important. It was data about vaccination because without it was important. So data that we collected data that we could justify the relevance for our problem. And then basically, if you are in the case of a modeling perspective, you need to see how to turn this data into estimates of the parameters of your model. Otherwise, if you are in a machine learning type of modeling, then you have different techniques. You have a technique where you will need to engineer some features and then feed these features into a supervised model, or you need probably you can feed data as a raw input into like some kind of deep learning that does not need pre-engineering features and use them for output. So this is my thought. So my thought will be collecting data that will be relevant for your problem, pre-processing it or not, depending on your situation to feed it into the model. But afterwards, once you run the model, you can go back to the loop and say, okay, actually, once I developed my predictor or my optimizer, what were the important features, the important data inputs that helped me optimize, or the important data input that helped me predict, so that later on, once you run your model into production, really focus your resources on this specific data.
So we take two last questions, please. The first.
Hello. First, I want to thank you for the presentation. It was very insightful and instructive. I would like to ask you, given a model and given some data, how to choose the best method using machine learning for treating this model. So, because I'm a beginner in applied math, and I would like to use machine learning in an approach of a model. So how can I choose the best way to approach it? Thank you.
Okay, thank you. So that's a good question, how to choose the right model. So I think that there are three types of things to have in mind when you want to choose a model. The first is, what is your setting? What are you trying to do with your model? Are you trying to predict something, or are you trying to do a clustering or to do something that is unsupervised? So there are some machine learning models that are supervised because you know the output. There are some machine learning models that are unsupervised, like a clustering framework or so. Now let's focus on the supervised ones. For the supervised ones, basically, you have a trade-off between trying to find some models that are simple, but that are interpretable. So you learn a tree model, a tree basically running a forest, or a tree-based model, or running a regression. The regression is interpretable. You can explain it to a manager, what is your coefficient and how do they play a role in your coefficient. A tree is also, or a cart is also interpretable, because you can explain what's your decision process. However, when you go to XGBoost or to a forest, then you lose interpretability, but you might earn some performance, right? So this is really like a trade-off to consider. And same for deep learning. You can use deep learning, but then in addition to the trade-off between interpretability and performance, there is also the size of the data set that you have and the nature of your data set. Because if you are like in a computer vision setting, then you want to go to deep learning. If you have a lot of samples of your data and you have a lot of features to consider, then you might consider deep learning for that. But here again, you might lose some interpretability. So once you run your model and you have your performance, you want to come back to your approach and try to interpret it. Because basically, if you want to develop a deep learning for computer vision in a healthcare setting, at the end of the day, you want to explain to your doctor what your model is doing. So there is an effort to invest as well in this side. So to summarize, I mean, there are a lot of parameters to consider, but to summarize, I would recommend to consider first whether you want something interpretable or not. Second, whether you have a large data set or a small data set, or the nature of your data set. And third, what is the setting of your modeling? Is it more supervised or an unsupervised approach? And I'm happy to take the question offline after. Yeah.
Okay, so my question is more of like the way of navigation between the theory and the application of mathematics. I think like I am about to talk about most of my class. Like we are studying the fundamental of mathematics. The problem we have is that we don't know how to link the mathematics with the theory. We all, like from the start of this conference, we talked about that mathematics in every field and the basis of everything. But when we go, like what we learn and what we see in application is like very different. It's like what we learn is like a very general, very advanced maths, but what we apply in is like the very basics, like it's just a portion of math.
Yeah.
So my question is like, if like me, I'm studying the fundamental of mathematics and I will go in research, inshallah. So how to like link it? It's like math, it's like a big sea with a lot of theorems, propositions and lengths and all of these equations.
Yes.
But at the end of the day, you find yourself sometimes just having to work with one or two, or
Yes.
and a lot of things is going with that specific field with a lot of details in that specific field and just a little bit of math.
Yeah, thank you. That's also like an important question. So, you know, there is no one answer to this question, because like it's a kind of philosophical question about the philosophy of science and mathematics, and we could talk about this for hours. I'd love to, but I'll share some thoughts though. From my personal experience, at least, I think that there are two sides, two ways to think about it. The first is our step one in the framework. What is an important problem? So, what is for some communities, there is finding like an advancement in the theory or in a bound that is theoretical is really important, because they believe that in the future this is what will this can have an impact. For some others, what is important is something that is practical, that have a direct impact on the ground that we could observe, or something that has a dollar value out of it, that we can get some money, or something that would improve some healthcare situation for a patient or for a population. So there are some that have a practical, some that have for some having a practical insight is what important is. So at least for these two talks, I'd like to say that we didn't start from the math. We didn't start. The math was just a modeling framework. We didn't start from the math. We started from global health and agriculture. Then we entered into this type of diseases. Then we developed. We understood the intuition, and then we came to the math. And the math that we used, especially in the first work, is very simple. It's like typical equations. It's not like some very advanced mathematics. However, we see that from that very simple model, and it's the same with the news vendor that Omar explained, from that really simple base case scenarios, we can derive some practical insights. Here is what is the sanitation that you use. Here is the variance that you can basically that you should focus on. So this is, I think, the way I'm thinking about it. But again, this is very subjective as a statement, because for some others, the advance in the theory is what matters, and I also respect that a lot. So. I think so. Yeah, I think that's finding the important question. If some people, as a researcher, we found ourselves very often rushing into the modeling, but like stepping back and taking the time to identify the important question and to build the intuition and to explore the literature sometimes can save us a lot of time down the road. Yeah, sure. So how do we move from something that is down the ground to a theory? Yeah. So I think that okay. So two ways to answer this question. So basically, the first one is, so you see this problem that we identified and that we have worked on. It's not something that I identified myself on my desk in my department down there. It's something that we were able to identify through interactions with field experts. So for instance, for the work on SARS-CoV-2, we talked to a lot of biologists, we talked to a lot of medical doctors before we went through the math. So I think that was like talking and interacting. So research is multidisciplinary by its nature. So we needed to talk to biologists, epidemiologists that understood better the field. We also went to the ground and we ran some surveys to talk to market managers, to talk to people that sell poultry and what were the risks that they are facing and what were their processes. So talking to people on the field was something that helped us shape our thoughts. Now, to move to as general theory, it's really a lot of reading. To be honest, it's really a lot of reading. So basically, once we identified these questions, we did like a massive literature review. We understood what's the theory down there so that we could identify the limits in there. And also, probably the third point is that often the innovation comes from the intersection of two fields. Often I'd like to finish with that. Like often the innovation comes from the intersection of two fields. So for instance, for the first work, it was the intersection of supply chain management and epidemiology. For the second, it was the intersection between computational biology and machine learning. So often the innovation comes from the intersection of two fields and discussion with experts from other fields. Thank you for that. Yes.
So my last question is quite far from the main topic that you have just discussed, which is I remarked that both of you have an engineering background. So my question is, how is it like to go from an engineering background to research background, especially that also I have that engineering background and I'm very interested on the research journey. So if you can provide me with more details, and especially that you are far from the industry, which is not the main reason why like we build engineers somehow.
Yeah. So, well, thanks for everyone for the patience. I'm happy to take this question, and it's a good question. So, from a career perspective, so basically the question was how to move from an engineering background to a research career, kind of. And here, I think that the backlash between engineering and research is really something that I don't believe in. I believe that research is inspired by a lot of engineering problems, and engineers and even industrials could benefit a lot from researchers. So to that point, I think that the position you could be in is basically to find a place or a research environment that will value your engineering background. You don't necessarily need to adapt yourself to some kind of research environment, but rather you can look for an environment, a research environment that would value your research background, your engineering background, because it is valuable. Second, probably from a practical insight, basically we all started with small projects. This, here we come after, this is some results of 4 to 5 years of work. And some work succeeded, some failed. There was summers where I wasn't able to produce any research, I was productive. And this is what happens for everyone doing a PhD or doing a research career. And we all started small, like through an internship or through a first independent project and so on. So I think this is, so find a place that will value your engineering background because it is valuable. And, starting from a spark and then fire will light. So, sure. Thank you. Probably I'll take it offline or should we allow it? What's it? Huh? Offline? Yeah. Sorry? Non, c'est peut-être pour l'audience. Okay, I'll take the question. So what is the question?
We don't all have the privilege of loving the theoretical mathematics. So do you think if you include the the applied approach of mathematics into education would make students love it more? Or do you think like math should be taught in the classical way, more theory, and make people just choose their way, whether they want to go with the more theory or more applied mathematics?
Yeah, okay. I think it's a combination of both. I think that we need, we don't, having practitioners only will not, help us make progress. And having theoretical people only will not help us make progress. I think we need a combination of both. We need to understand the theory, and we also need to really motivate the problems. If I had the solution to that, probably I think that a lot of educational systems are thinking about this problem, how to combine between theory and practice. I think that we need both. We need both to understand the theory, to go in depth, and we need to understand the practical side of it. To do that, we need to probably give even more important. Math are quite important. I'm really happy to see how math is getting some level of importance in Morocco, and we see that in the diaspora. There is a lot of diaspora that is working in math-related fields from Morocco. So this is really very encouraging. And I think that we need a combination of both. But I think that we should not forget the theory. I think that the theory sometimes, often the theory is the pillar of our foundation. It helps us be more confident in the models that we develop. And at the same time, we also need to motivate the progress. So we need to do everything, but we have only limited time. So we really basically need to be involved with Math&Maroc and with other organizations to, continue working on math-related fields. So this is my answer. It's not, it doesn't give like an ABC answer to this question. It's more like we need to do both. But I think that there are a lot of people working on developing policies, educational policies for that.
I take the next question. Thank you so much.
Thank you.
So thank you for this wonderful presentation, and thank you again for accepting the invitation. Also, I would like to thank Mustafa was there for helping us in organizing this congress, and a special thanks goes to the team of the University of So that's it. Thank you everyone for attending this conference and for your active collaboration. So thank you everyone, and hope to see you soon in the next conference, inshallah. Also, I would like to